students. Thank you for joining me in this class. Today we are going to learn about DC transient. So as you can see, before introducing this topic, we must know some of the definitions. The first one, a DC transient, are quantities whose value are determined after a certain period when they get to reach a steady state. Transient refer to the change that takes place when a quantity rises from zero to steady state. Then a time constant is the period taken by a transient value to rise from zero to steady state value or vice versa. Now, in this topic today, we are going to discuss about the type of DC transient. And the first one is called RC circuits, and the second one is called LC circuits. And later, we can also talk of RLC circuits. Later, we can talk about this one. Now, today we want to talk about RC circuit. RC circuit. And you can't explain this without a diagram. Therefore, let's draw the diagram. Let's draw the diagram. This one is a resistance. Maybe you can draw different with the inductance. This one is the capacitor. And then this is a switch. And then here we have our resistance. This one is our RS, R of S, V of S. And then this one is our capacitor. Then this one is our R of L. Now, when you want to calculate this, let's say, if you can remember about Kirchhoff's law, is what we are going to say to use now. We are going to say during the charging. So in RC we are going to calculate during the charging, or when the resistance capacitor circuit is charging. Now during charging from Kirchhoff voltage law, we have that Vs is equal to VR plus Vc. Our Vs is equal to that voltage crossing the Rs, that is the area, plus Vc. Now, but we know that VR is equal to IR. Therefore, Vs is equal to IR plus Vc. But I is equal to C dVc divided by dt. Now, let us replace this one in our equation by removing this I. So we are going to say Vs is equal to CR dVc divided by dt plus Vc. Okay, I can divide my body into two here, so that the second thing what you are going to do is to collect like terms. You collect like terms, and that is Vc, Vs minus this Vc come to this other side, minus Vc is equal to CR dVc divided by dt. After that, we are going to separate the variable. Separation of the variable is in the ordinary differentiation. If at all you have a problem with that, kindly make sure you follow and you like. Separating of variables. variable. So when you're going to separate this variable, we are going to have dt. The dt divide by CR is equal to dVc. This one is V, dVc divided by Vs minus Vc. Now we want to integrate. Now integration. We are going to integrate this. Therefore, let's integrate d of t over c of r is equal to integrate d of Vc divided by Vs minus Vc. We are going to integrate that. So when we integrate that, on the right side we are going to have, for example, this one we are going to have t over cr. When we integrate this, we are going to have t over cr is equal to E of Vs minus Vc. Is equal to E of Vs minus Vc. Maybe we can clear this other part, so as we can work on this board. So, replacing the initial condition, let us replacing the initial condition, at the start of charging, therefore at the start of charging, t will be 0, our time will be 0, and also our Vc will be 0. Therefore, replacing this one in this equation, we are going to have, for example, this one we are going to have 0 divided by Cr is equal to E of Vs minus 0. So this one, of course, is going to, when you integrate this, remember, after integration, we are going to introduce a constant. There is a constant here, Cr plus the constant K. Therefore, meaning that 0 divided by Cr plus our constant K is equal to In of Vc minus 0. Therefore, this one is going to come, K is equal to E of Vs. Let us replace this one in this equation. Let us replace that one in our equation. We are going to have, now we have the value of this K constant. Therefore, it is T divided by Cr plus our K, and the value of K is E of Vs is equal to E of Vs minus Vc. Therefore, after here, what we are going to do is to collect like terms again. Therefore, we are going to have T divided by Cr is equal to E of Vs minus Vc minus E of Vs. Using the law of logarithm, using law of logarithm, in these logs we are going to have T over Cr is equal to E of Vs minus Vc divided by Vs. Vs minus Vc divided by Vs. After here, we are going to use a natural log, or let's say getting natural log, or natural logarithms. And we are going to say this one is 1 over t, 1 over exponential t over Cr is equal to Now we remove this A, that is Vs minus Vc divided by Vs. Divide by Vs. I hope you can follow very well. I hope you are following. I hope you are following very, very well up to where we are. Now, of course, we have now E. Now we have E. When this exponential, when you put it, or when you use law of indices, we are going to have E negative T over CR is equal to Vs minus Vc divided by Vs. Need to know that, therefore, we multiply both sides by Vs. Multiply both sides by Vs. So this one and this one goes. Therefore, we have Vs E of negative T over Cr is equal to Vs minus Vc. Now collect the like terms. Collect the like terms. Collect the like terms. When you collect the like terms, therefore that means this Vc will come to this other side. Therefore we have Vc is equal to Vc, this side is positive, Vs is one negative minus Vs e power negative T over Ci. What is common there? Vs, therefore Vc is equal to Vs, open the bracket, 1 minus e power negative T over Ci. E power negative T over Ci. So after this one, you will be forced to draw now, you sketch the graph. Sketch, or the graph. Let us draw the graph. Let us draw the graph. The graph will be in this position. So remember not to forget about don't forget this formula, because we are going to use it. Vc is equal to Vs, open the bracket, 1 minus e power of negative T divided by Ci. And this is how you should drive it. That is how you should drive it. Now at the maximum here we have Vs. We have time at the maximum, and the graph will look in this direction. When you sketch it, that will be our graph that says Vc is equal to Vs 1 minus e negative T over Ci. Over Cr. Kindly take your time to see that. And then you need to note that our Cr is tau, or the time. You need to note that. I hope up to there you are good. Now, you need to know that Cr is equal to tau, or the time constant. Time constant, and it have a symbol like this one, sometimes tau. It's called tau. It's called tau. Now, let us determine the curve for the charging current. Let us now determine the curve. Let us determine the curve for the charging current. For the charging current. Therefore, we know that, or you can recall that I is equal to C dVc divided by dt. But Vc is equal to Vs, open the bracket, 1 minus e power T divided by Cr. Therefore, we are going to replace this one here. Therefore, we are going to say I is equal to C d over dt, open the bracket, Vs minus 1e negative t ci. Therefore, we are going to take the constant outside. Therefore, the constant is this and this. So I is equal to c, let's say VSC. You differentiate this. When you are going to differentiate this, remember differentiation. If you haven't tackled differentiation, kindly have time to. So when you want to differentiate this, you are going to have 1, let's have the bracket, 1 over CR. 1 over CR because this T is constant. That time is constant. Exponential e power negative t. And then, remember, we also have a negative here. So this one will have a negative. But this negative and this negative will be a positive. Therefore, this is the equation that we are going to have. Therefore, but remember that I'm trying to calculate, to do some few calculations so that I can confirm whether we are sailing in the same boat. Therefore, remove this one outside here. We are going to have VSC divided by CR e power negative t over CR. If you can look, this one and this one will go. Therefore, we have VS. Therefore, we have VS divided by R e power negative t over CR. But we know that I, using Kirchhoff's law, I is equal to VS divided by R. Therefore, our equation will be 1 I replace VS over R e power negative t over CR. Now, when we want to sketch the graph, when you want to sketch this graph, now, we are going to have a graph of t against I at the maximum where it's 0 and replace a 0. Therefore, our graph will come in this manner. This graph we are going to say IE of negative t over CR. That is the graph. Now let's see the voltage across the resistance. See, can have a look of it. Maybe some question will be asked to derive this formula. So make sure you take it very serious, especially when you are doing engineering courses. So the voltage across the resistance. The voltage across the resistor. Is given by the voltage across the resistance is given by VR is equal to IR. But we know that I is the value of I. This value is equal to I. I is equal to E negative T over CR. Therefore, take this one and replace here. What are we going to have? We are going to have VR is equal to IR e power negative TCR. Therefore, but we know that VS is equal to IR. This one using Kirchhoff's law. I hope you can remember that. Therefore, VR is equal to Vs e power negative t over CR. Let us sketch the graph. Sketching the graph. You are going to have, this one is the graph, at the maximum of VR and the time taken at 0. Therefore, our graph will be in this manner. Our graph will be in this manner. And that, let's solve just one question. Let us try to solve one question. We'll try to example. This is our first example. The 4 microfarad capacitor in series with 100 kilo ohms resistor is to be charged by being connected to 20 VDC supply. Determine the time constant. Number 2, the initial charging current. Number 3, initial rate of growth of potential difference across the capacitor. Number 4 is the potential difference across the difference after the time equal to the time constant. And then the time taken for the capacitor voltage to reach 18 voltage. Now let us try to solve this problem. Solution. Let's solve with number 1. Number 1, it reads time constant. In the time constant, we have a symbol of tau. Time constant is equal to CR, or C multiplied by R. C multiplied by R. So, what is our capacitor? Our capacitor is here, 4 microfarad. That is 4 multiplied by 10 power negative 6. Multiplied by the resistor. What is the value of the resistance? It's 100 kilo ohm. That is 100 times 10 power 3. 100 times 10 power 3. Let's take my calculator and try to solve this. And that is 0.4 seconds. 0.4 seconds. We have solved part Roman 1. Let's go to Roman number 2. The initial charging current. They are only asking for I. What is the total I? I is equal to V over R. Whereby V, what is the total voltage? We have 20 divided by the resistance. The resistance here is 100 times 10 power 3. And that is 0.2 milliamperes. 0.2 milliamperes. Question number 3, or Roman 3. The initial rate of the growth of the potential difference across the capacitor. Very good. Question number 3. The initial rate of growth of potential difference across the capacitor. Now we need to know that I is equal to C dV, C divided by dt. Right? I hope you can remember that. Where dVc divided by dt, is equal to I divided by C. dVc divided by dt is equal to I divided by dc, which is equal to, what is the value of I? The value of I is here, that is 0.2 times 10 power negative 3 divided by the capacitor. The capacitor we have 4 times 10 power negative 6. And that is, that is 50. This is 50. Let's see if I've calculated. That is 10 power negative. 50. Yes. 50 Vs, because that is the voltage. Very good. So that is 50. Let's see the second question. 50. You can say 50. Let's go to the Vs. Vs. Now let's go to the last question, second last. The potential difference across the difference after the time equal to time constant. And that is Vc. In our formula in Vc, we derive that Vc is equal to Vs 1 minus E negative T over Cr. Therefore, Vs is equal to 1 minus E power of negative 1. Why? Because this Cr, it is the same. The question asks the time equal to time constant. Therefore, if we say we have time constant is the same, therefore we are going to have E power negative 1. Therefore, in this one, tulipata hii ngapi? What's the value of Vs?